Hello, 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 hello.
Just working.
Did you test it? Hello, hello.
Damn.
This one, hello. It's on. It's not working. Oh, okay.
Took the wrong one.
Testing. Okay. Sorry for the late start. Today we'll be talking about natural language processing. So just to get a quick raise of hands, how many of y'all were here for the last couple of workshops? All right, cool. Okay. So just to recap for the people who weren't here last time, um, basically a big summary of what we've covered is just like this thing over here. For the people who have been here, this is going to be like repetition, but it is an important concept. So this is basically the structure of most machine learning problems, and that is we have some inputs and an architecture which makes a prediction, and then we have labels, which is what we want what predictions we want from this model or architecture. And we basically take the difference between our prediction and the labels of what we want, and then basically update it such that this architecture or model gets better at making those good predictions. So that's kind of the structure of machine learning just generally. And that's why I'm bringing it up again, because we're going to be looking at a different task today. So, what is natural language processing? If y'all saw it, just ignore it. So to get a raise of hands if anyone knows what NLP is or would like to guess. No one? Okay. So what NLP is like the aim of making machines understand human language. And what that means basically is the words I'm saying right now, a machine doesn't really understand that. Or I guess I could encode it into machine language, but it wouldn't understand what the words mean. So like when you and I hear the word tree, we imagine like a tree, like a physical tree in our mind. So what we're trying to do is basically have some understanding and give it to the machine. That sounds very abstract, but that's the general goal, and that's where everything stems from. So, to like, if any of y'all are familiar with ChatGPT, that's one of the biggest breakthroughs in NLP stuff recently, and that is where it does question answering pretty well and like generates new text pretty well. Another task of NLP is translation, and that is where it converts some words to a different language. Any of y'all want to take a guess at what some other tasks could be? Maybe I'll give a hint. It's pretty similar to some of the things we've seen last time. Okay, so some additional tasks it can also be useful in is classification. So taking a piece of text and classifying it as one class or another. In this case, it's hate speech and not hate speech. So this one's kind of a bit memey. It's just one word difference. But yeah, so that's one task, classification. Another one's summarization, like taking a big piece of text and summarizing it. So if y'all like remember English in high school, it's like the things you read instead of reading the whole book. So that's another task that's pretty useful. So to remind you all what we saw so far and like kind of reinforce the ideas we've seen. So what inputs have we seen so far? Some of them are simple features like size, which could be like 16,000 square feet, age, just a simple number like 10 years old. And other things we've seen are images, which is also kind of encoded in numbers to represent like hue values, I guess. Um, so just to remind ourselves of what we've seen, and we can see how we can move forward with this. So any of y'all want to take a guess at how text is kind of different from these two? So we have simple numbers here. We have groups of numbers in like matrix form. How is text kind of different from that?
Text is a lot more like abstract and like harder to kind of put in just like a raw data form like that.
Mhm. Yeah, that's correct. Not that there's a wrong answer, but anyone else want to take a guess?
Words kind of depend on the other words.
Yes. So there are relationships between words, and they're not necessarily. I mean, there are relationships here, but it's not as clear. So one thing I wrote down was not straightforward. So like, how does a number? I mean, how does words just become numbers? How should we divide them up to make them numbers? So it's not as clear as the other ones where everything's already basically in number form. And when we want to use like some form of machine learning model, we have to have a number form. And then also in text, local information is not as important as we saw in images. So for example, if we go back here, local information means like what's next to each other in a region. So like it's important to know where like the edges are. Therefore, it's important to know like how things correlate in like little regions. So that isn't as important as it is in images. So that's the difference between images. And additionally, it is also a sequence. So kind of how in images we have different sizes of images, in text we have different sets of text. Okay. Anyone want to take a guess at how we can convert these text sequences into encoded numbers? Or just, yeah, numbers. It might not be as complex as you might think. So like, for example, this sentence, yes. I forgot the question mark, but yes.
Do you just have some sort of dictionary that corresponds either each letter to a number or each word to a number?
Yep, exactly. So what he said was where we would have like a dictionary. So like if I made like an encoding system, I can make H equal to like 0, O equal to 2, W equal to 3, something like that. And that's one way of converting words and text into number sequences that can be used in like machine learning. But it is kind of two parts. So the first thing we need to look at is how are we going to divide up these words or letters into like smaller little pieces? Because some parts are more frequent than others, and like we want to make it as meaningful as possible, so it can be easier for a model to learn the the mapping between like the input and what we want it to be. So it might be harder for it to just learn like the meaning of just like these little letters, but we can make it a bit easier for them and just make it unique to like each individual word. But then again, what if we have a bunch of like words that aren't commonly occurring, then this one may not work as well. So we might want to split it up even further to little pieces of words that are common. So like prefixes, suffixes, stuff like that. Like stuff like that, yeah. And that's the last one, which is subword level. So these are the three main ways of dividing them up. Character level, which is probably the simplest. You just divide the characters. Word level, which is also pretty simple, but it faces a problem of like, what if the word's not been in the training set? So what is that gonna be? And then subword level, where it's more into like common little subphrases in text. Okay. So kind of as he said, one way of turning these little phrases into numbers is simply encode them into like different values. So here we just have different integer values of what we're encoding these words as. And here we choose 0 for and, example is 1, and hello, and so on. And it's encoded as different numbers. And what you might be thinking here is the numbers we're giving these words, they're just kind of random. And you would be correct if you are thinking that. So what some people do is they try to make these numbers a bit more meaningful. And we call those, there were a lot of different ways of doing that, but we call them basically embeddings. And that just means like a meaningful numerical representation, kind of. It sounds very complicated, but it's kind of simpler than you would think. So to go back to the problem with words is, or the task we have been looking at, let me go back to those. So in ChatGPT, what are like the outputs to the prompts we give it? Is it like simple class? Is it like one word? Is it like 10 words? Or is it variable? So what we can see here is that from previous things we looked at, like classification with images, finding little boxes in the images that represent different classes, stuff like that. This is a bit different in the sense that our outputs, or what we want it to produce, is kind of unbounded, and it's just a sequence that can be as long as possible. So like, an answer to how is your day can be like, my day really sucked, you know? Or it could be like, my day was really great and I got to meet the president of the United States. Like, I don't know what the output length is gonna be. So that kind of leads into a problem we face in the previous architectures we had. And that is that the output size is kind of just one. It's kind of limited. It can only produce like what we set beforehand. So if I wanted 10 outputs, I would have to know how many outputs are going to be there when I train the model. So that's kind of a limitation we face in like just a normal neural network. And in addition, like a convolutional neural network, which we looked at last time, where we basically had the little images. We had these images, and then we kind of mapped over like portions of them with different weights. So that solves one problem, and that is the variable length of the input, but it doesn't produce variable outputs. So to kind of solve this problem of variable inputs and outputs, we kind of had to find a new architecture of doing things. So just to see if any of y'all are like thinking a bit ahead, anyone have any ideas on what this new architecture can be? Or like, yeah, maybe take a guess. Well, okay, it's fine. All right, let's go on. So what we're looking at now is kind of what we call recurrence. And it's basically the neural network we saw before, but in a for loop. So what we do is instead of just like only producing one output, we feed the previous output back into itself and give it another input. So that's kind of how this works. And that is where we have one input as the first word, and we pass that along to the next, the same itself, and then we pass in another word, and then we pass in the output here back into itself again, and then another word, and so on. So what does this do? It basically can have variable inputs, and it can have variable outputs, which are the top things. So this is useful in scenarios like translation, where we might want to produce the output text of, let's go back to the previous slide. Like in the right, I like turtles should be me gustan las tortugas. So what we could do is, in this new way of doing things, we can take these little words and each word should output the translated word in another language. Or that's the idea of it. So to make this idea a bit more clear, I want y'all to kind of work through this problem. I know I've been doing a lot of these where I just have y'all do it by hand, but I honestly think it's probably the best way of doing these. So to make it like a bit more clear for y'all how this works. So what I'm gonna have y'all do is basically convert this sentence over here into its little subwords and encode them. So kind of what we just described. And then I want y'all to kind of emulate the idea of a recurrent neural network. So to make it a bit more clear on what I want y'all to do, I'll write down the steps. So the first step is we're gonna be dividing the words into subwords. And then encode these subwords and then encode them into integers, which is just like 0, 1, 2, 3. And then we're gonna have to basically simulate like this idea of what's happening here. I'm gonna make it simple for y'all, and we can just use one neuron for that. And that neuron, that neuron would basically be taking in two inputs. One is gonna be the previous output, and one is gonna be the encoded subword. So I'll just show y'all how that will look like here. And then y'all can kind of go and fill it in yourself. Oh yeah, after, like later on after this, we're gonna have like a little quiz. I'm gonna try that out to see how y'all like it. So hope y'all like that too. Y'all can get started on this if you want, but I'm gonna write down the last part, which is the recurrent neural network. So take the words, how is your day, split it up into little parts, encode it into numbers, and then run it through a recurrent neural network. And I'll show y'all how the recurrent neural network will look like. So go ahead and get started on the encoding part first. Can y'all see this, or should I make it bigger?
Make it bigger.
Make it bigger? Sorry. And just so we all have like kind of the same answer, I'll make W equal to, what's a nice number? I'll go easy on y'all, 2. Okay, so just to go over how this equation works. All right, the mic's back. So H just stands for hidden, and it's supposed to be like the output of the neural network, I guess. And as you see on the over here, the X is the text input. So after you encode this, that would be X0. And after you encode this, that'll be X1, X2, and X3. So what we want to do here is we're going to basically have an output for each word, and that is H. So there should be H 1, 2, 3, and 4. And for X 1, 2, and 3, and 4. And we're going to multiply the X times this weight, and then we add that times the previous output times the same weight. I kind of simplified it for y'all, but this is kind of the idea, and it'll make it easier for y'all to understand what's happening. So we should have 4 outputs and 4 X's. And I want y'all to go and calculate that. Any questions? Concerns? Okay. Do y'all want paper? Raise your hand if you need paper. Or can you not see it? I'll go around. Oh, what's up?
This is the current relation, right? So what's the base case for current relation?
So,
H of 0, H of 1.
so in this case for H, we can just say 0. Like the first H is just going to be 0. So you kind of just drop that section. Yeah, I didn't mention that, but yeah. So I'm gonna go around and ask y'all if y'all have any questions. And they can also help. So just raise your hand if you need help. So basically you want to fill out this, and X's, when you encode them, just encode them as 1, 2, 3, and 4. Just to make it simple. So you just encode it as like a sequence of integers. Yeah. Just use 1, 2, 3.
Yeah, so A is 1.
You can do it in whatever order you want, but just do it like that. Just so we can all type it, get the same answer. Type it. Do
Yeah, I was supposed to use this. Yeah. So,
I just follow the steps. It's like,
There were steps.
like,
Yeah.
and then, so you can find doing something creating he was explained it actually
He does something. Yeah, it does something. Was that fun? I felt like he just the word. Yeah. But I heard. But I heard, hey, if you want operations.
So, yeah, it's just a, somebody, he's saying like, he's something, yeah. That's just from us. That's probably better. Yeah, you did it. Like one from nine to each number of each of one way to you how you do and then you use it just plug it and each is like you're gonna go medium and the starting case you just have to clear. Yeah.
it's like E1,
Yes. So what I would do next, and it was the next up there. Okay, but and that next up, yeah, I'll be yeah, it's just like simple multiplication. So it's nothing complicated. Yeah. But yeah, you're right. You want to say it? I'll do it over with you so you can check it. But if you have any questions about how this works?
So are we just like, you mean like coding the, was there data coding?
He's just going.
Or just like generally, if there is any questions about it, I'm sure.
Like I was just something else.
I don't believe so. I think I understand this.
Yeah.
Nice. Yeah, any questions?
And you use that.
Afterwards?
It's funny, it's like, you explained step one, I was like, okay, fine, and step two, you're like, encode it, I was like, okay, step three, you're like, yeah, and it's running through a recurrent neural network.
Yeah. But luckily, it's not too complicated.
Yeah, you said it right at the formula. It's like,
Yeah. All right. Let me know if y'all still need a bit more time. Just raise your hand. Okay, seems like everyone's good on the time aspect. I'll just go over it, and hopefully, if you got it wrong, I can show you where you got it, where to fix it. So I'll just simply split it up into 4 words. I'm gonna erase this. So I'm gonna split it up into word level because I wanted this to be pretty simple for y'all to do. And then I can just assign these words its own values. 1, 2, 3, and 4. And then we can just multiply it times. We can just use this equation. So to fill out this section, and 1 times 2 is 2, and then plus 0 times 2, which is 0. So it'll just be 2 for the first one, and then for the second one, it's going to be 2 here times 2, and then plus the previous one, which was h1 times 2. 2, and then you multiply that by 2 again. And then once you calculate that, that would be 8. And then I'm going to go about and do it again. So 3 times 2 plus 8 times 2 equals 6, and then 16. And you add those two together. That's 32. 22. Sorry. Simple math. This is why I have a computer. And then lastly, 4 times 2 plus 22 times 2, which will be 8, and then plus 44, and then that would be 52. So if y'all want to check your answers, that's kind of how that works. All right, any questions about this process? I'm going to go over a bit about why we do it like this and how this can actually be made larger and more larger so it can handle more complex tasks. So any questions about this process though? No? Okay, sounds good. Let me just check the time. Okay, so this is kind of the recurrent neural network process, and the idea is in this image, the A is going to be like a linear layer, and we're just feeding it back into itself. And that's why I had you all kind of go through it manually and do it, because when I first learned about it, it just looked pretty weird to me. I didn't understand what it meant, so that's why I had you all do that. And the idea is the same as just normal neural networks, and that is we still have weights in here, and we're just gonna update these weights, and we're gonna make it produce better outputs. So to be a bit more abstract, I don't know if this is gonna be helpful for y'all, but recurrent neural networks basically try to learn how things change. So that's why it's kind of better for these sorts of tasks like language processing. So before we had convolutional neural networks, they learned little features on the images. This one learns how things change. And that's kind of the idea with like it going back into itself. So these weights are going to be optimized to learn change between words. That made it very more abstract. But what we can do to make this actually usable is we would just have more weights, and maybe the H can be more, and that's basically it in real, and add like an activation function on it. Okay, so kind of what I just described, we would have our inputs, the X, as we said, which is going to be a text sequence. And then we have our parameter, which is the weights. And that will go into our architecture, which is this little function over here. And it'll make a prediction. And then we'll have our labels. So like H1, we might want that to be, I don't know another language off the top of my head, but we can just say Bob was fine today. That can be the expected output. So that could be our labels, and then we can look at the difference between these outputs and our encoded version of Bob had a good day. And we would want to update these weights over here such that it produces that sort of output. And a question someone in the back had earlier was this encoding scheme, it seems kind of like it affects the output of this equation a lot. So like if I arbitrarily chose like 3 as yours, it's gonna make these look a lot different than it would have otherwise. So in practice, what happens is to kind of help out that, we take these numbers and then we feed into a linear layer to kind of get an embedding. So we take these encoded things and then we try to get like a more meaningful version of the numbers, kind of. So that will also be optimized. So generally, everything in machine learning, you just optimize it and then it gets better. I don't know if that made sense, but okay, I guess I'm missing that slide. So next, I was going to explain what the labels will look like for different tasks. So we looked at a couple of things today, or we looked at a couple of tasks today. I'll just go back to those. So one was just simply generative question answering, and then that, how they do that sort of labeling is a bit different. So let's say our model produces 2, 3, 4, and 5, and then we decode it and we get the words how. Wait, let's make it an answer to how is your day. So I get this decoded values of my days is nice, and that could be kind of close to what we wanted. So let's say the actual things were supposed to be my day sucked. I don't know why, but maybe. And so I'll just make this clear, prediction, real. So my day is bad. What we would do is basically we would take these and encode it again. Because I just decode it so y'all can see what it means. So maybe this is like 10 or something. And we can just add these all up and minus them. And then we get some form of a difference. So in actuality, these encodings would be a bit different. I made it pretty simple so y'all can understand it. In actuality, it will have like more meaning after it's been trained a bit. So these numbers, we would add them up and then we'll subtract them from what we had before, and we'll get a loss. And we use that loss as I described in the deep learning section, where we use the loss, we take the slope of it, and then we update the parameters, and then the whole optimization process occurs. So that's one task, which is question answering. Another one, like translation, it can be similarly done, and that would just have like the words in like French or something, and it will be done basically the same way. So something y'all might be thinking about is in this way of showing it, I've only showed it where the output is going to be the same size as the input. And that is a problem. And what people do to solve it is we stack two recurrent neural networks on top of each other. So one produces hidden outputs, the other takes the hidden outputs and produces another sequence. And that allows more variation in the output sequence. That sounds pretty abstract though. Okay, so next is just simple classification. What we can do is instead of looking at all of these outputs, we can just look at the last one. And then we compare the difference. And that's how classification would do its labeling. So to make it a bit clearer, my prediction, like it has those hidden outputs still, but I only care about the last one. So I want, like, let's say I wanted to say hate speech or not hate speech. Or good and bad. So good be good and bad. Instead of producing a sequence, it just produces one output, which is a lot easier. And similarly, it can just do the loss thing and update the parameters and so on. And same thing with summarization. We would have like two recurrent neural networks stacked on top of each other. So I'm gonna draw that image real quick. Or I can just search it up. Encoder. All right, let's see. I'm gonna stop presenting this. Show you the screen. So this has like little blocks. These are just the same neurons, but it basically produces the same outputs, the hidden ones, and we just feed it into another one, and that produces a second form of sequence. It doesn't have to be the same size as the original one. And this is like very core to like a lot of modern NLP application where there's a sequence input and there's a sequence output that isn't necessarily the same. So out of this, I think I covered the core architecture stuff. And basically for different tasks, we just have different ways of labeling it. And then we optimize it all the same way as we've done in the previous classes. So any questions about this? This or anything I just mentioned? All right, cool. We're gonna have a quiz. So he's gonna have this set up. Go ahead.
What do you want? Which one do you want?
I don't know.
You don't care? Okay.
You can do classic. Just continue with Google.
Okay. Yeah, just do. Oh shit. Okay, let's continue.
All right. So this is kind of like Kahoot, but it doesn't cost money. So yeah. You can join. Oh, it's off. I'll also show the QR code. And the format we're going to be doing it, y'all can just answer it asynchronously. I don't have to like show y'all. Wait, yeah. because we kind of don't have that much time left. But yeah. All right. Just raise your hand if you got it down, so I can go ahead and start it. Okay. You good? All right. I'm gonna start it real quick. So we got 9 participants now, and we can start that off. 5, 4, 3, 2, 1. All right. So y'all can like answer it independently on your own screens, and in the background, I'm gonna put up the last slide, which is the sign-in form, while y'all are doing the quiz, or once you finish, you can sign in on the right. Just to track y'all's. That's fine. So some of those questions we haven't covered. That's fine. We're going to be covering them next workshop, where we're going to be going to more modern stuff like attention and large language models.
Ask how many people might show up to like a fall workshop just to see.
I think they're a bit busy right now.
Just after.
Who's winning?
It's on the screen.
Oh, okay, I can. Okay, Josh.
It's on the screen.
Dang, ramen, you're doing pretty well, whoever ramen is. Yeah, it's
Roman thing.
Oh, Roman, my bad. It was pretty far for me.
Son.
Oh no. And once you're done with the quiz, we have the sign-in form on the left, so you can go ahead and do that after. Does this have any music?
Maybe.
I mean, I don't think you guys plugged in anyways. It just sounds so quiet.
I'll experiment with the next one.
Oh, it has music. Nice. I don't think I can. All right. For some of y'all, so we're gonna have a follow-up workshop for this one, where we're gonna be implementing the recurrent neural network and like a couple of other NLP tasks in code. I know here we're talking about more high level stuff, and some of y'all did express the interest of wanting more code stuff. So we are gonna be having follow-up workshops for that. And do you want to talk about that and tell them when it's gonna be?
Hello. So for the follow workshop, we're going to be having it at Wednesday at 8 p.m. We'll also have like the location on the Discord as well. I just want to ask who would be willing to show up to a follow workshop at that time? Just raise your hand.
You said this Wednesday at 8.
This Wednesday at 8.
And we're thinking about doing like every Wednesday after the Monday workshops for coding.
Yeah, so
No.
it's going to be like all code basically.
Yeah.
So,
Wednesday at 8 is when the AIN meets. So,
So raise your hand if you're interested in like the coding workshop follow-ups. Okay, and it's like the time a problem for y'all because we can try to have it moved. What about the rest of y'all? Is like the time a problem? Raise your hand if it's a problem. All right.
I would say raise your hand if you wouldn't go.
So we kind of cover like the stuff we've been doing here, where we kind of implement that from scratch, like the recurrent neural network. We implement that in code, and then we'll cover more like framework-driven, actually using models and using it on tasks, and like training something that works.
That's kind of what I was planning on doing.
Yeah.
So what I was thinking about for this follow-up workshop, we can basically make like a very simple recurrent neural network using like TensorFlow. I don't know who's familiar with that. TensorFlow. Should I use PyTorch?
Yes, it's PyTorch.
Alright, we'll see about that. But, so that's kind of yeah, Wednesday at 8 p.m. It's at a different.
Yeah, just like other people here, so we can do that. But y'all should all sign in if you haven't already, and then y'all can go ahead and leave. And if you have any questions for me, just come up and ask. What's up? So it's right below. It's a bit small. 924. It did not work.
I think that's.
Do what?
is that guy saying you can't do it?
There was one person.
Okay.
No, two people. What?
Like Discord link on website, social media stuff.
For what?
Like there's like a link with all the social Instagram, Discord.
I don't know about the website. I haven't looked at it. You can ask Mark. He's like knows everything about the website. All right.